the question that a lot of people have is psychology valuable? They say psychology really isn't a real science. I mean, you have like physics, and you have biology, and you have chemistry, but psychology, it's not a real science because you're just making predictions that are wrong some of the time, right? And you say abuse leads to criminals, but my brother, he was abused and he's not a criminal. Right? So people say things like that. So the question is, can you be okay if you get things wrong sometimes? And the answer is, yeah, better than chance is a lot better than nothing. So casinos, right? Casinos, they don't win every bet, right? If they won every bet, would people go to casinos? No, people wouldn't go to casinos. If they wanted to, they could just go to the door and hand over their money and walk away, right? People go to casinos because there's a chance that they might actually make some money, right? But overall, the odds are in the casino's favor. And it doesn't have to be in the casino's favor much, right? If for every $10 that people spend, or that people gamble, the casino just makes $1. And if they're doing this millions of times a day, right? People gamble $10 million, boom, you just made, $1 million. And they're not getting everything right. They don't win all the time, but they win more often than not. So with psychologists, deeper isn't always better, right? We talked about transfer appropriate processing, and we said in certain situations, deeper processing isn't necessarily better. However, if we don't know anything about those other situations, it'd probably be a good idea to do some deeper processing, right? Therapy might not help everyone every time, but therapy helps a lot of people, right? And therapy has been demonstrated to be better than nothing. So if you take a group of depressed people and you don't do anything with them versus take a group of depressed people and give them therapy, the people that get the therapy end up doing better than the other group. More than we would expect just due to chance. Not every abused child becomes a criminal, but if you don't want your kid to become a criminal, maybe it would be a good idea to refrain from abusing them so you don't increase the likelihood that they become one. Does that make sense? This doesn't mean that if you don't abuse your kid, they won't become a criminal, but you're decreasing the chances, you're decreasing the odds. Okay? All right, so today we're going to talk about experiments. So my PhD is actually in experimental psychology. Experiments are my bread and butter. Experiments are awesome. Let's go back to the question about, does abuse cause criminality? How can one figure out if abuse caused criminality? What could you do? What do you need to do? You could use a survey, and what do you ask on this survey?
For example, choose some people who is Christian.
Okay. So we find people who are criminals, right? We go to the jails, and then we give them a survey, and we say, were you abused when you were a child, right? And what else do we need to do? I mean, maybe we find out that 40% of them were abused as a child. Does that mean that abuse leads to criminality? We need more information.
You need to check normal people.
Yeah, we need to check non-criminal people, right? So we go to the prison where they have criminals living there, and then maybe we go someplace else where there aren't criminals hanging around, and we give them the same surveys, right? Now if we find that the prisoners, the 40% of them were abused, and that 30% of the non-prisoners were abused, but this is different than what you would expect due to chance, then you can say, yeah, there's some evidence that abuse leads to criminality. Not in the sense that if you're abused, you're going to automatically become a criminal, but it increases the likelihood. Remember the slide from last class, it said that these abused children were 11 times more likely, right? So it wasn't that it always leads to it, but it's a statement of probability. We need to measure abuse some way, and he said we can measure abuse by using a survey, right? We're going to ask people, were you abused? abuse here is the independent variable. Can someone give me a definition of an independent variable? Taha. What's an independent variable? What does it mean to be independent? Who here is an independent student? Who here is independent from their family? Three of us are independent from our family. What does that mean if we're independent from our family? Yeah, if we are independent, that means we're not relying on them. Now, I'm not completely independent from my family. I call them for social support, but I don't rely on them for money. I am financially independent. I make my own money. I don't ask my parents for money. Does that make sense? So I'm financially independent. So an independent variable is not a variable that we think is depending on something else. We think it's the variable that another variable depends on. Does that make sense? So abuse, this is the thing that we think affects criminality, right? So abuse is independent. Criminality, on the other hand, is dependent. We think that the criminality depends on abuse, right? Just like the rest of you depend on your parents. All right, so the independent variable is thought to cause change. The dependent variable is a variable thought to change. It's the variable thought to depend on the independent. And the question we're asking with this is whether or not these two variables go together more than we would expect by chance. If there's a relationship between these variables that we can't just explain by chance. Does that make sense? So how do you measure abuse or criminality? This is a question of operationalization. This is a big word, but the idea is pretty simple. So to operationalize something means that you define the operations necessary to either measure something or manipulate it. Okay? So when I asked earlier, does abuse cause criminality and how can one know? He operationalized it. He said, we're going to operationalize criminality by going to a prison, right? Or with the help of Ubedullah or someplace else, right? So we're defining criminality on whether or not you're in the prison or out of prison. We also operationalized abuse. That was a survey question. So how can we measure abuse? We can absolutely do the survey question. Are there other methods that might be better? Why might asking someone if you're abused not be a great idea?
Police reports?
You could look at police records. Why might police records be better than asking someone, you know, were you abused?
Most people do not prefer their age.
Yeah! Like, I don't want to answer that. Was I abused? Maybe that's a bad memory that I don't want to think about. Or maybe, you know, I want to seem like, no, everything's fine with me. So people might not want to answer that question honestly, right? So we could look at other things. Police records. How can police records indicate whether someone was abused or not? Yeah, you might not look at the police records for that person, but you might look at the police records for the parents. And if the parents abused that kids, they may have been arrested for child abuse. Does that make sense? Are there other ways we could measure abuse? Are there other ways we can operationalize this variable of abuse? Lots of ways. What else? With police records and ask them. We could look at medical records, right? So we could look up at someone's medical records and see how many times they came to the hospital for injuries, right? So abused kids should probably be coming into the hospital with more injuries than the non-abused kids, right? We don't want to look just at sickness because we don't think that, you know, being abused leads to flus necessarily, right? But we do think maybe abuse leads to injuries. So there are advantages and disadvantages of operationalizing abuse in lots of different ways. So we talked about this one. People might not want to answer this correctly. We could ask participants' caregivers. Did you abuse this person when they were young. Again, we face the same problem. Who's going to say, oh yeah, I abused my son, I abused my daughter? Right? This isn't something that people might want to ask. You can look for scars, right? People who are abused are probably going to have more scars. We can examine the medical records. We can install cameras in people's homes. Very Orwellian, right? Install cameras and we're going to watch. Big Brother. And we're going to see how many times the parents smack their kids, right? Now, this actually is probably the best way, in one sense. Later we're going to talk about reliability and validity. So when I get to that, if I forget, please remind me about this and we'll talk about why this might be a really good method for measuring abuse. All right, how do we measure criminality? We could go to the prisons and someplace else, right? There should be more criminals inside of the prison than outside of the prison, but there's some problems with that. Could be that you have a bunch of criminals who are there and they're not in prison now, but they were last week, right? So what might be a better way to measure criminality? Go to the police, yeah, see how many times they've been arrested, see how many times, maybe not even that they've been arrested, but how many times their name shows up on the police blotter, right? So you could look at arrest records. What else? Again, you can just ask them, are you a criminal? But we run the same problem that we do with saying, did you abuse your child? Right? You can ask participants' friends. The participants' friends might be a little more honest. Yeah, dude, oh, Jimmy? Yeah, he's selling drugs like crazy, right? We can get prison records, get arrest records, or we could install cameras everywhere and just follow the person around and see every time that they take a protocol without paying for it, or do anything illegal. All right. There are different ways that we can try to answer these questions. There are correlational methods, and then there are also experimental methods. The first method that Abdullah Bilal suggested is a correlational approach. You're looking to see how two variables correlate. That means how well two variables go together or not. We're asking, is there a relationship? When one occurs, does the other one also occur? If we abuse someone, does criminality also occur later on? So imagine that we get medical and arrest records for 100 adults. Okay, we operationalize abuse by looking at their childhood medical records for injuries and their arrest records for criminality. So we find that the childhood hospital visits for injuries are related to arrest records more than we would expect due to chance, right? So we claim, aha! Yes, these two things are related. So more abuse leads to more criminality. What's the problem with this? What if we find that criminals were more likely to be injured as children? It's not always causative. There's a famous saying in statistics, regardless of the discipline that you're studying it in, and it's that correlation does not imply causation. Just because you have a relationship doesn't mean that one thing caused the other, right? There could be something else that caused both of them. So, what other explanations could we come up with that we might be able to explain both of these things without this necessarily leading to that? What if they're not only criminals when they're adults, but they're criminals when they're kids, too? Right? If they're criminals when they're kids, might they have more injuries? Why? So if they did a crime and someone catches them, they might get a beating for it, right? Or maybe they don't get caught, but they're jumping over a fence or something and they fall and they get injured, right? So it's possible that the reason that they have these injuries in the first place is because they're already criminals. Does that make sense? There are lots of other things that could be wrong too. And the things that could be wrong with the study tend to differ in terms of whether it's a problem with reliability or a problem with validity. So who can tell me what reliability is? What does it mean if something is reliable?
It has to do with precise value. precise measurements, consistency.
That's what I'm looking for. Not necessarily precision, but consistency, right? So if we have a reliable measurement of something, we're going to get consistent results every time that we do it, right? So now, how reliable is our method of looking at medical records to see if the kid was abused? How reliable is this? Are we going to come up with the same answers each time we look at the medical records? You say no? What do you say, Sumaya? Yes or no? No? How about you, Ashinra? Yes or no? No? Raza? Yes! Yes! You got it. Ring-a-ding-ding. So, if we have their medical records and we're counting number of injuries that they have in their medical records, as long as we're being careful, we should come up with the same number every single time that we do this, right? So I look at your medical records, I count them up, 1, 2, 3, 4, 5. He was in the hospital 5 times for injuries, right? I give it back to him, I come back later, oh, I lost my data. I need to look at your medical records again, I count it up, 1, 2, 3, 4, I should get 5 again, right? If he's an adult, his childhood records aren't changing. If he's a kid, we might see more, right? If they've aged a little bit more, they might have more time. But if the time period that we're looking at is set, that's not going to change. What if we ask someone if they're a criminal? Or, I'm sorry, if they were abused? How reliable is that? It would be less reliable, right? Why?
Because of bias.
Maybe someday I ask them, and they're feeling bad, and they want to talk to someone, and they say, yeah, I was abused. Right? But then I lose my data, and I come back to the same person, and I say, oh, I'm sorry I have to ask you again, but were you abused as a child? But they're feeling different. They don't want to admit that they were abused. They feel guilty for having told me this earlier, right? So they say no. So I can ask the same question 2 different times and get different results. I hate these ear thermometers. Have you guys used these? Like sometimes I feel sick and I use this ear thermometer and I read it and it says you have a fever. And I'm like, oh man. And then I take it again. And it says like, you're fine. Does that happen to anybody? Where it like varies quite a bit? My favorite type of thermometer I can't find anymore. It's the one with the mercury. You have to like hold it in your mouth for 5 minutes. It's a pain in the butt to do, but you get the same answer every time. The mercury thermometer is very, very reliable. This ear thermometer, not as reliable. Make sense? Because we're coming up with different answers each time. As Sunday said, it's not consistent.
About these medical records in the hospital, the child himself might have gone to different hospitals and he might have been looking at different data.
That's true. So if we have a problem, let's say one time we looked at one hospital's records and another time we're looking at a different hospital's records, then we have a reliability problem. Because you're absolutely right that the records are going to vary from hospital to hospital depending on how often they came to that hospital or not, right? But if we're smart in the design and we get all the hospitals' medical records, right? So there are some initiatives to make one database that has everyone's medical records, regardless of which hospital or which doctor they went to. If we had something like that, we should have very reliable answers. But that's a good point. Okay, the more similar the answers are each time you do this, the more reliability you have. Validity, on the other hand, is what?
Accuracy.
With what?
Accuracy.
Is there a different way that you could say that? So he said it has to do with accuracy, but I'm looking for a little bit different.
It's how applicable it is.
Yeah, it's more, it has more to do with like this applicableness. Maybe it's how accurately you're measuring what you think you're measuring, but it's not accuracy in a precision type sense. This is basically the thing. Are you measuring or manipulating what you think you are? So with a thermometer, this one that I put in my mouth, I want to measure temperature. Does it measure temperature? Yes. It measures temperature. If I put this thing up to my ear and I, take my temperature, does it actually take my temperature? It does. It does register temperature. It's not as reliable as this other thing, but it's still valid. If I have a higher temperature, if I do this over and over again, the average is going to be higher than if I have a lower temperature and do this over and over again, right? So they're both measuring temperature. Imagine that instead I had a computer randomly pick out a number. I'm good with temperatures in the States. The Celsius conversion has me a little confused. 37, is that the average temperature? So imagine that you have a computer randomly picking numbers between 37 and 40. Okay? So I'm measuring temperature that way. So I go up to you and I hit my computer and it's picking out a number. And I go up to you and it's picking out a number. Is that valid? Am I actually measuring temperature? No, I'm not measuring temperature. I'm measuring the random table in the computer. Does that make sense? So if something is valid, that means you're measuring what you think you are. So when I'm measuring arrest records, how valid is this? Am I really measuring criminality? I'd argue that I am, but there's some problems with measuring criminality by looking at arrest records. What type of criminals get caught?
Criminals get caught.
Yeah, which criminals get caught? This is an easy answer, yeah.
There might be discrimination against a certain group of people. Black versus white.
Oh yeah, that's a perfect example. So the town that I grew up in was very white when I was growing up. And we had a really bad reputation for pulling over black people. The police, you would see the police, they pull someone over, and you could bet with your friends if they were pulled over a black person or a white person. And if you bet black, you win most often. Even though there weren't many black people in the area, they sure got pulled over a lot. Right? So that might not be the most valid indicator of criminality. Because imagine that you've got Kurds and you've got Turks. And you're monitoring the Kurds much more closely than you are the Turks, right? So whose crime are you more likely to detect? Which crime are you more sensitive to because of the bias and which way you direct your attention? The Kurds, right? So it is still measuring criminality, but it's measuring something in addition to that too. Good. Yeah. I'm sorry?
You will say to remind you.
Oh, yes. So imagine that we install the cameras in people's homes, right? And we're measuring the amount of times that they're smacking their kids. Is this a reliable method to detect abuse?
No.
If they didn't know.
He says no, you say yes. Why not?
Because the same thing doesn't happen every day.
But the camera's in there. If abuse happens, do we pick up on it?
What's about if they abuse that money you have?
I'm sorry?
If the child is abusing the country.
If they're abusing the car, we miss it. But it would reliably indicate abuse that's happening, at least in the range of the cameras, right? I would argue that that's a very reliable way of measuring abuse in front of the cameras, right?
Yeah.
How about valid? Is it a valid way of measuring abuse?
Yeah.
I would say absolutely. It's probably the most valid of any of the other things that we said, right? Because the injuries might not be due to abuse at all, right? The asking, big problems with that. So this is a very valid way of looking at it. Why don't psychologists do this when they're interested in study of abuse and criminality? Why don't we install, cameras in people's homes? Yeah, there's a problem with privacy, ethics, things like this. This would be really, really invasive. All right, if we're really measuring things that we think we are or manipulating the things that we are, we have high validity. So our study where we're measuring the abuse by looking at medical records and criminality by looking at police records, this is a very reliable way of looking at these things. You should come up with the same answer every single time that you do it. Talked about less reliable methods. How valid is our study? Our study doesn't have problems with reliability, it has problems with validity, right? It has problems with extraneous variables. So the extraneous variables are any variables other than the independent variable that might also affect the dependent variable. So our independent variable was abuse, and our dependent variable was criminality. But as we've talked about, lots of things could affect criminality. Poverty, personality, your ethnic background, right? Police bias. So our study is very reliable, but it's not very valid. If the extraneous variable is correlated with the independent variable, we have a confound. So if we have a confound, this means that we have some type of confusion. It means we can't tell whether the independent variable or the confounded variable caused the change in the dependent variable. Yeah?
Each child was not abused,
Okay?
and it became a criminal through the influence of his parents.
So the influence of his friends, this is peer pressure, right? This is an extraneous variable. It's something that can also affect whether someone becomes a criminal or not, okay? The influence of his friends, the influence of his parents, potentially how good of a school they went to, how wealthy were their money. In our study, we have lots of uncontrolled extraneous variables and several potential confounding variables. So we might have poverty, genes, personality, education, peer pressure, lots and lots of things. Imagine that genes are related to criminality. This suggests an obvious confound, right? So if genes are related to criminality, maybe criminals are more likely to abuse their kids, right? It's sort of a crime to abuse someone. So if they're criminals, they might be doing more of it. So they're abusing their kids, but what else are they doing? They're passing their genes on to their kids. So maybe it's not the abuse that's leading to the criminality, it's the genes instead. Does this make sense? This means that we're confused. This is what a confounded variable is. When you're confused, is it this or is it this other thing? Oh, I don't know. That's a confounded variable. Personality. Maybe extroverts are more likely to have real accidents because they're going out and doing things with their friends, and more likely to get arrested because they're going out and doing things with their friends. Poverty. Maybe poor kids are more likely to be abused. Their parents are stressed out over money, so they're more likely to hit their kids. And as they grow up in poverty, they're more likely to steal a portacol or a loaf of bread. So other things could cause, well, you've got confounds. So a better method, this is an even but more valid method, is to do an experiment. Now this is highly unethical. We shouldn't do this at all. But if we did, we'd have really good data about the link between abuse and criminality. Let's adopt 100 random orphans. Okay? We're going to go to orphanages all over the country and randomly select 100 of them. Then we're going to abuse half of them. We'll pick who gets abused by flipping a coin. So we'll randomly pick which out of the 100 are getting abused. Alright? And then the same people that abuse the half that's getting abused, they play with everybody when they're not abusing. So it's playtime, everybody. Let's play. Okay, abuse time. See you guys later. Right? There are 4 components of true experiments. The first one is random selection from a population of interest. Now, in the study I suggested, we didn't have completely random selection. Why? If I want to see if abuse leads to criminality, did I say I'm interested in abuse and criminality for orphans only, or am I interested in everyone? If I'm interested in everyone, but I only look at orphans, it's possible then I'm not actually measuring a link between abuse and criminality in everyone. I'm just looking at a link between abuse and criminality in orphans, right? So that's a problem, because I didn't randomly select from everyone. This means that the results of my study really only apply to orphans. Okay, what if instead of randomly adopting 100, we took 100 for the same orphanage? This would further limit the generalizability. Maybe it's only, orphans from this orphanage that this happens in. If you went to another orphanage, it wouldn't be the same thing, right? Okay, once we have our group of participants, we want to randomly assign them to treatment or control groups. And this random assignment is to control for extraneous variables. Because here are my 100, and some of you are smart, some of you are not smart, some of you are Kurdish, some of you are Turkish, some of you are males, some of you are females. But if I randomly assign people to the different groups, then I should get, on average, the same number of Kurds and Turks in each group, the same number of men and women in each group. There are going to be slight variations, but these variations shouldn't be significant, beyond what we would expect by chance. If these variations are significant beyond what we would expect by chance, then we have a confound. But we do this random assignment to control as best we can for the extraneous variables. If we assign 50 boys to be abused and 50 girls not to be abused, we said, girls are cute, I don't want to hurt them, but the guys, I have no problem whipping them. Right? If we did this, then really we're not looking at whether abuse in orphans leads to criminality. We're looking at in fact, we're not even looking at does abuse in boys lead to criminality, because we have no appropriate control group to compare them against. Right? True experiments, part 2. Control. Some things we want to make constant. So we can eliminate potentially confounding variables. What if the abused group was abused by one person and the non-abused group never saw this person? Remember when I initially said it? I said the same person that does the abuse is going to play with everyone? Why did I say this? To control. Because maybe if I didn't have them play with everyone, it's just that person. For some reason, being around that person is what makes people be criminals. It's not that they were abused, they were just by them. That was enough. Right? It's a confound. But by making sure that everyone interacts with this person, we can ensure that it's not just simple contact with the person that leads to criminality. So these things are all methods of reducing the probability that differences in the two groups, dependent variables, will be due to the influence of extraneous variables. Basically, all these things are to eliminate confounding variables. And I apologize for going late, but we got a really late start today. See you guys next class. Okay, so at the beginning of class, we were briefly reviewing signal detection, and we were talking about bias and sensitivity and how they affect people's responding and whether or not they're getting hits, false alarms, misses, or correct rejections. Now, I said that when people are insensitive, that means they're not sensitive at all, only bias matters. And when only bias matters, we're going to have this pattern where the hits is equal to the false alarms and the misses are equal to the correct rejections. Now, there was some confusion in class because there were some differences in reference frames that people were using to talk about the problems. So I wanted to go over this again to make sure everyone's on the same page. So here we have our outcomes matrix. We have the coin. Imagine that heads is the signal. So the coin, if we flip it, the signal can be present, it's heads, or the signal cannot be present, not heads or tails. We also have our responses. So we might indicate that the signal is present and say heads, or we might indicate that the signal isn't present. It's not heads, it's tails. So if we look at the outcomes for the coin and our responses, we create this matrix. Here the signal is actually present. We said it's present, so we have a hit. Here, there's no signal present. The heads isn't there, but we said it was heads. So we have a false alarm. Here, the heads was present, so we had a signal, but we said, there's no signal. What signal? I didn't hear a signal, didn't see a signal. So this is a miss. Signal was there, but we missed it. And finally, there was no signal present, and we didn't say that there was a signal present, so we correctly rejected this. Now, the question is whether or not these statements are true. If only bias is operating, are the hits going to equal the false alarms, and are the misses going to equal the correct rejections? Imagine we take a coin and we flip it 100 times. On average, we should get 50 heads and 50 tails, or not heads. If we are completely insensitive, this means basically we're flipping it blind. We're flipping the coin, but we can't see the result. If that's the case, then the only thing that should affect our responses is our bias, right? Whether we're biased towards saying that a signal is present, heads, or we're biased towards saying there's no signal present, tails. So imagine the situation in which you're biased to saying heads 60% of the time. This would mean that you're saying not heads or no signal 40% of the time. Now, if we flip the coin 100 times and we get heads 50 times, if we're saying heads 60% of the time, how often should we get hits? How many hits should we get? So we multiply 50 by 0.6, we'll have 30 hits. Since we had 50 heads total, if we hit them 30 times, this means that we missed the other 20. So we have 20 misses. We could also do this by multiplying, right? 50 times 0.4 equals 20. If we look at not heads, so we had 50 not heads, but we're saying 60% of the times that, yeah, there was a signal there, so we're going to have 30 false alarms. 50 times 0.6 equals 30. And finally, there's no heads there. We're guessing no heads 40% of the time, so we should get 20 correct rejections. Now, the important thing to notice here is that the hits and the false alarms are equal. Also, the misses and the correct rejections are equal. Now, of course, in a real coin flipping experiment, we might not get exactly 50-50. So we might have some small variations. Sorry, it should be 19. Right? But the variations aren't more than what we would expect by chance. Right? And if we did this repeatedly, on average, we would find the numbers that I presented earlier. So, if only bias is affecting things, then we should get our hits equaling our false alarms and our misses equaling our correct rejections. Okay, so I forgot to resolve the problem that arose at the beginning of class due to using a different reference frame, so I want to resolve that right now. So I asked a question that went like this. Imagine that we have someone who's completely insensitive to heads or tails, that is, to the signal or not the signal. And imagine that they're biased to choosing heads 60% of the time. Now, in this situation where they're completely insensitive and they're biased 60% of the time to saying heads, how often, what percent of the time when heads comes up are they getting a hit? Now, if we have a situation where we flip the coin 100 times and they're biased towards heads 60%, we're going to get 30 hits. So the percent of time that we're getting a hit when heads comes up, so we're getting hits, 30 hits, divided by 50 heads, this equals 60%. So if we're biased 60% to saying heads, when heads comes up, we're going to get it right 60% of the time. When we don't have heads come up, we're going to get it wrong 60% of the time. Now, the reason that there's some confusion is when I asked this question, one of the students responded not in terms of the heads, but in terms of the whole series of flips. So if I had reworded the question differently and said, if I flip the coin 100 times and we're 60% biased towards saying heads, what percent of the time will we get hits? Well, that would be simple. We have 30 hits. We flip the coin 100 times. So we have 30% hits when we're counting all the flips. And 60% when we're just counting
the heads. Hope that clears up the confusion.